Excellent. As I'm sure everyone is aware, if you want significant dynamic behaviour on the web, whether you want features on a website or whether you want to have a fully fledged web application, the browser will be executing JavaScript. JavaScript is the language of the web. It had quite a rough start as a language, but since then it has matured, it is now widely accepted, it's used to build many things, many projects are built on it, many businesses are built on it. There is a huge amount of code in the world based on JavaScript. In fact, it's claimed, only slightly fatuously, that any application that is possible to write in JavaScript will one day be written in JavaScript. Now, despite the topic of this talk, I don't actually have any personal beef with JavaScript. I think it's quite possible to write elegant code in the language, as long as you stick to the good parts. This is quite a mandatory slide in any JavaScript talk, so I'm glad to have got it in early. The problem I have with it is it's too easy with dynamically typed languages to sort of cut corners if you can't be bothered, or if you're not really thinking, if you're not sure what you want to do, you just slap some code down. You end up writing code that's just full of all these assumptions, and it's difficult to communicate these assumptions to future maintainers. And on big projects, that can be a killer, because the faulty assumptions really are the cause of a great many bugs, and they can often be a cause of a great many very subtle bugs that only arise in unfortunate situations. Personally, one approach I like is to be able to communicate assumptions and requirements and prerequisites and guarantees in the code by encoding it in a type system, which requires using a strongly typed language. And I like to leverage the type system as much as possible, because the more information the compiler has about how the code should work, the more ability it has to catch mistakes that you're making. There might be simple mistakes, like mistyped function name, or it could be a more subtle mistake, like you've got a function, and you give it some input data, someone in the future changes that, so it mutates that input data. Never used to mutate the input data, code elsewhere presumes you'll never mutate the input data. This is going to end up with some horrible, hard to track down bug, and it'd be really nice to be able to avoid that. If we can make the compiler aware of these assumptions, instead of just having them in your head and then throw them out into the world, the compiler can actually catch some of these, can catch code that you write that sort of undermines these assumptions. Before you even execute it, that's the great thing about having a compiler and static analysis, that helps you catch logic errors earlier. Generally, the earlier that you can become aware of a bug, the easier it is to fix. Now, I'm not the only person that thinks that strong typing is good. Even languages which have been staunchly weakly typed or dynamically typed, people are coming around to try and add strong typing to them. Famously, Facebook was written in PHP because it was really easy to just start hacking things out. Loads of people knew PHP. It's really easy to hire people for PHP. But once your project gets large, this flexibility and convenience from not having to worry about types actually can become a bit of a hindrance, and it makes it difficult to reliably change code. Very hard to see what repercussions any changes might have. So to try to help with this, Facebook created a language called Hack, which is backwards compatible with PHP, but allows you to put types on top of it. Another language renowned for being weakly typed is Python. And people are working on adding optional typing for that as well. Dropbox are working on that, and they're working on that with the guy who originally created Python. So presumably, he thinks it's an idea worth presuming, or they're just paying him a huge amount of money. Going back to JavaScript, Microsoft have released a technology, developed a technology over years that allows you to add type annotations to JavaScript called TypeScript, and Facebook have been doing something similar with type checking called Flow. Not everyone agrees that this is a great idea. Uncle Bob Martin, who's one of the co-authors of the original Agile Manifesto, he says that static typing is not required if you have 100% unit test coverage. I've never worked on a commercial project that has anything like 100%. So I'm not sure how applicable that advice is. Maybe it works for him, that's great. Another example is the Clojure language, which is created by a guy called Rich Hickey, and he believes that the cost in specifying types is too great for the benefits that you get for it. I would like to make light of his opinion based on the fact that he looks like Sideshow Bob. But actually, he is really sharp, and I have watched several talks that he's done, and they're really insightful. I'd like to just say maybe he's the exception that makes the rule. But then I've also heard people who interpret his comments about strongly typed systems as he just hasn't found one that he likes, that he doesn't find one that he's think that the cost-benefit trade-off is right, as opposed to him being against them in principle. I've got a few reference slides coming up at the end of this talk, and one of them is a link to a video in which Rich is talking about his opinion on type systems. I think it's worth a look because he is an interesting, clever guy, and he does good presentation. Right, so far I've only said that what I really want to do is have strongly typed system when I'm writing this code. And I've already mentioned technologies for JavaScript that allow you to do that. So why am I so excited about using C#? Well, I personally have a good relationship with C#. It's my friend, I've got a lot of experience, most of that good. I enjoy writing it. And where I work, we use it for all the server-side code, and we enjoy a lot of benefits from that. It's well known, it's relatively easy to hire people, as easy it is to hire good people in Liverpool for anything. It's mature, the language is stable. .NET Core, they went a bit wild with that, but that's stabilising down a bit now. There's a lot of libraries for all the different tasks that you might want. It's generally fast and efficient enough. And if you really need to eke out more performance, then you are able to, tune that using built-in diagnostic tools in Visual Studio. There are great third-party tools for it. The biggest win really is the tooling. Visual Studio is very powerful. To be honest, we sort of take it for granted these days because if you stop and think about everything it can do, you can write the code, you can document it in the type system, you can document it in the XML summary comments, you tie all this together through IntelliSense, you get that with external dependencies, you get it through external dependencies that you can expose through a shared repository like NuGet, and no individual item on that list is unique to Visual Studio, but the integration, how tightly it works together in Visual Studio is pretty magical. On top of which you have the .NET compiler platform, which was originally just called as Roslyn, and I will continue to call it Roslyn because otherwise it's a mouthful. It's built into Visual Studio. It allows you to add new forms of code analysis. You can teach the compiler about particular code patterns that is applicable to your project, help it catch more mistakes in the static analysis process. I'm not going to go into a lot of detail about that, but it is something that I use on a regular basis. It's not just one of those, that sounds like a nice idea, but I'm never going to do it. Quite a few of the NuGet packages that I publish include analyzers to help people write code right with the libraries that I'm putting up there. So it's the tooling, and particularly the code analysis, that's really won me over. It's the idea of using Bridge, because you can use Visual Studio to its strongest, and you can access NuGet for distributed packages, and you can write analyzers, and you can write C#. And the Bridge compiler is what takes C# that I write, translates it to JavaScript, which I can then run in the browser. It's fully open source. It's available for personal and commercial use with no paid license, so it is free to use the compiler. The source is on GitHub, you can run issues there, it accepts pull requests. I've had a few pull requests in there. All the contributors have made their mark, so it's not just a team that's locked down, it is real open source, if you like. The easiest way, this is going to be a bit of a touchy subject, the easiest way to get Bridge into one of your projects is to use NuGet. There's no configuration required, in stark contrast to a typical JavaScript front-end project, which would use gulp and grunt. Last year, I tried picking up TypeScript again to see where it was at, and I was really impressed with all the features they've been adding recently. I think as a language, as a project, is really interesting. But I tried to set up a solution that would convert my TypeScript to JavaScript, that would bundle all the files, that would include React, that would convert TypeScript unit tests into JavaScript unit tests, that would run the unit tests, that would run TSLint to make sure I wasn't making any silly mistakes on writing non-idiomatic code. I don't know that I actually got it working. If I did get it working, it wasn't pretty, it wasn't fun. I read dozens of articles and guides about how you're supposed to do this, but JavaScript practices just seem to move so quickly. It's hard to catch up, never mind to keep up, and there's so much conflicting advice out there. Whereas Bridge, you just install it via NuGet into Visual Studio, and it works, and that's it. What's also nice is you can get all the libraries for Bridge, or bindings for the libraries through Bridge, through NuGet. Now this is the bit that I've written in my slide. I'm going to attempt a live demo now, but I tried it on my laptop earlier, and I feel like it's had a hard life, Mike. I think bad things have been done to it. So it's probably for the best. I opened up my finger with a kitchen knife recently, and I can't type very well. So I've got some slides which all have these little notes saying skip if demo went well, which now is sad. It's as easy as this. Create a new project, class library, my first bridge project. Go to NuGet, add bridge. In the class 1 file that is in a class library project, add a main method, which is the entry point. Write something exciting like console write line. Build it, and then what it will do is not build a .NET binary. What it will do is build JavaScript files, and it will automatically create a HTML scaffolding file. So after building, if you go to bin debug bridge, you'll find an index HTML file, and you can load it in Chrome, and there you get your message. Super exciting. Now we could change it and do something more like what we're likely to do with web stuff, which is to use the DOM. If you want to create a DOM element, use document.createElement, exactly as you would in JavaScript, but all of this has got bindings and it's strongly typed. So when we're setting in a HTML, it knows that it's a string, it's not an object or a number or some nonsense like that. When you call pen child, it knows that it wants a node, which is what we will get back from document create element. If we were to run that, then we would see it in browser, and instead of hello in the console, we would say hello in the DOM. Now, if we want to do what all the cool kids are doing and use React, then we can add that into our project in two goes. There are two packages we need. One is bindings for React. Because what you want with a strongly typed language like this is not just to be able to talk to React, but to be able to talk to it in a strongly typed manner. So the bindings are how you talk to something wobbly like JavaScript in a strongly typed manner. So we add the bindings, NuGet, just search for bridge React, and you'll see it, descriptive text, bindings for bridge. Then if you don't want to have to load React from a CDN or something, you can add this package as well, and that will actually pull the library, the JavaScript library, to your application. Then we would have changed the code to look like this. Instead of setting in a HTML directly on the document, we would have created the document and then started rendering, created the container to add to the document, and then we would have started rendering with React. Very exciting. Right, I've got some more code that I want to look at. Now I'm aware that this is too small, so you don't have to hurt your eyes trying to read it. What this is a custom React component. Now I realise that not only is this text too small, but not everyone might be familiar with React. It doesn't matter, I'm not going to spend too much time talking about it. I'm just going to dip into it briefly because I want to point out the point of these bindings. It is, as I said, to talk to the library in a type-safe manner. The key part about this class are that it inherits from this base class, which is how React is happy that it's a particular type that it can use as a component. And we use generics to specify what classes should be used for props and states so that they're fully type safe. And it's to show that the React life cycles are overridden, again, in a strongly typed manner. Now all this component does is show a label and a button, and as you click the button, it's telling you how many times you clicked it. Very, very not exciting demo, but it's enough to show React state management. So if we run it, click it, just go. What have you said about the hardware switch, Mike? Awesome. Okay, good, excellent. Going back to the code, the onClick handler is declared an anonymous function. It calls the base classes set state to re-render. So Bridge is totally happy to take fat arrow lambdas in C# and convert them into JavaScript. Any sort of binding magic that would be required will be done behind the scenes. Bridge emits ES5 JavaScript. Fat arrows did come in ES6. I've sort of lost track of what browsers support ES6, so I don't know if ES5, ES4 is fixed. If anyone cares, but if you need ES5, Bridge is there, it's extra compatible, excellent. I think it supports IE11 as the oldest browser, and then everything else modern, so Edge and Chrome and Firefox and all the rest. I'll have to check on the website to be sure. But right, now I've hopefully shown how easy it is to get up and running with Bridge. Now I really want to get into C# and why C#. I want to reinforce why C# is a better choice by tightening up some of this code. In React, props and state should be immutable. And that means that once you have an instance of these types, they should never be changed. So when you want to set state, You don't change a property on an existing state instance, you create a new state object and you pass that to set state. There are a lot of notes in the React documentation about this. There are a lot of articles. State reference must not be mutated. It's everywhere. But in the earlier code that we saw, the state had a click count field that was immutable, and so in the future, someone tinkering around with that class may forget this must not mutate state rule and try to poke about with that property directly. Now, if the state class was immutable, that wouldn't be possible, and we can change the code accordingly. So in this case, the state class is immutable, and we have the new, explicitly a new version of it up here. It's not possible to monkey about with the existing instance. Now this goes back to what I was saying earlier about encoding assumptions and requirements into the code. When it's not possible to do the wrong thing, then it's not possible to forget to do the right thing. One downside to writing immutable classes in C# is that it's a bit arduous, particularly if you need to take an existing reference and change one property. You need to call the constructor and pass all of the arguments that it takes. It's not too bad here where we've only got one argument, but if you've got a more complex site, that gets annoying very quickly. To try to alleviate that, there's another NuGet package which I've published for Bridge, which makes creating immutable classes easier. It makes it easier, particularly to do the copy and change one prop thing. Perfect.
We'll stop that at night.
I'm not going to go into a lot of detail about what that package does. It's kind of out of scope of the talk, and I could go on about it for a while. There is a link to the GitHub repo in that references slide at the end, so if you want to know more, you can look there. The interesting part here is that at the top, instead of having to new up a new state, there is this magic with method where you can set one property and you can change that, and that will give you a new version of it. Now, that is very handy if you've got a complex type which has got 10 properties on the entity and you just want to change one. You might also notice if you're really eagle-eyed that click count is now a uint, which just means it can never be negative, which also harks back to what we're saying about using the type system as much as possible. Click count isn't a concept that could be negative, so why would we be using a type that could represent it as being negative? Now I want to incorporate even more wisdom into the code. In answer to a Stack Overflow question, what are 5 things you hate about your favourite language? John Skeet said that he thinks classes should be sealed by default. If anyone doesn't know who he is, which I suspect with so few people here you all do know who he is, he's got the highest reputation of anyone on Stack Overflow, recently passed 1 million, which is just ridiculous. He's answered something like 36,000 questions. Now, I don't just agree with him because of his insane reputation. I also think that if you're going to have a class that you should be able to be deriving from, you should be designing how that inheritance should occur. And until you've thought about how that should occur, it shouldn't just do it by accident. In fact, I'd go a bit further and say that I think 99% of classes should either be sealed or abstract or static. There are very, very few places where it doesn't need to be one of those. Whether you agree with me, which you should, whether you agree with me is kind of by the by. The point is just to further illustrate the benefits of Visual Studio and C#. So I have published another NuGet package that includes an analyzer to identify this. So if you add this to the project, and if we added it to the project, this is the code that we've been looking at so far, you will see squiggly lines and warnings in the error list. I say you can see, but it's quite small. You can see squiggly lines and warnings telling you that it's recommended that you should make everything abstract or sealed or static, or if you're in that 1% of times where you really do think you've designed it and it shouldn't be any of those, you can put a little attributes on it. So in this case, it makes sense for all of them to be sealed. That would make the analyzer happy. And we'll end up with classes that actually they make more sense. We've taken assumptions about how they work and we've enforced that with the type system. Not only have we said that the state class should be immutable, which we did before, we've also said that we shouldn't be able to extend the state class through inheritance because the component isn't going to know what to do with the derived class of the state. The state is the state. There is no state plus some extra stuff. This is really valuable for code maintenance because it gives anyone, any future maintainer, any future person, access to more information about how to use the code and it's not in a document somewhere which the A won't read, B is probably out of date. It's in the code itself. Not only do they have access to see that information, the compiler has access to understand that information, and it will warn them or it will refuse to build if they break those assumptions. So, hopefully I've done a reasonable job so far of explaining why I think C# on the client and server is a win for typing and the tooling, but I'd like to throw in a few bonus features. Since we're using the same language on the client and the server, we can actually share some code between the two. For example, API request and response classes. So say we had a .NET web service on the back end in the solution that the client is talking to. It could be web API, it could be .NET Framework, it could be .NET Core. It doesn't really matter, it's just an endpoint that we talk to in JSON. In the solution, we can add a shared project, which is a way to share classes between multiple projects. Now, if you're not familiar with that funny symbol, I should have maybe put shared project in quotes, because normally what you would do to share types between projects is to have a shared assembly or a shared reference. Bridge projects are a bit special. When you add the bridge and NuGet package, it gets rid of all the .NET system references and replaces them with its own. And these ones are special, and they can sort of compile down to JavaScript. Now, you can't have a project which has both. So you'd have the back-end web API, uses the real .NET system references. You have your front-end bridge project, which uses the bridge system references. If you wanted to share an assembly between the two, that wouldn't work, because it would need to reference the net system ones and the bridge system ones. So what we do is, maybe if we were being ungenerous, we would call it hacky. You add a shared project, which is just a sort of extension of shared files. So any project that references a shared project, behind the scenes pulls all of those files individually into themselves. And so you have a version of person details built as bridge, and a version of person details built as .NET. So it's a way to share files, but it lets you share those classes between front and back end. Now the final piece of the puzzle is that the bridge team have released a version of JSON.NET that works with bridge. It's not as fully featured as the full .NET version, but it does the job. You can send messages back and forth between server and client using shared types that they both understand, which is very powerful and very convenient. I did consider ending the talk here, and that would have fitted into the original time pretty well. But I've been talking about quite, enterprisey stuff about server and client, and maybe you just want to write JavaScripty stuff that just only lives in the browser. You're not interested about server and client, you don't care how easy it is to server APIs, you just want to do more DOM and browser work. For example, someone I work with wrote this Pong game just to have a play around with bridge and see how it would work in the browser. He wrote this blog post about how we've been able to do it in 20 minutes. Which gives me a very convenient point to talk about this URL deck.net. It's a really, really easy way to try out Bridge, even easier than installing a NuGet package into a new project. It's online, and on the one side you get your C#, and in the middle it will translate into JavaScript, and then on the third pane it gives you a live, interactable JavaScript implementation, if you like. If you've ever seen the TypeScript playground, it's like that, but it's better because it has that live preview, which the TypeScript one never did. The JavaScript preview is quite interesting because it lets you get an idea of the bridge JavaScript output. I realise that you won't be able to see it from here because it's small and blurry, but it's quite clean and you can take my word for that. Or you can try it out yourself, because in the references slide there is a link. There is a link to this Pong game. On the whole, it's good. Now, say you really don't like JavaScript and you don't even want to see JavaScript in your browser, Bridge will generate source maps, and that means that you can see C# in the dev tools. So if I go back to the demo code from earlier and change it so that it throws an exception as soon as we get going, then when we break in the dev tools, you'll actually see C# in there, C# in there. I realise the text is small, so pow. Organised. On top of that, if you want to poke around with variables and whatnot, you can do it in the panel on the right. So those references, which is C# references, you can sort of poke around with. Now the code so far, I've looked at code that talks to DOM, which there was some in the original demo that I just went through quickly. The Pong game just talks to DOM. I looked at code that talks to React. In both cases, there's bindings to existing libraries for type-safe access. The DOM code and the React code talk to the browser DOM, and they talk to the standard JavaScript React library. There are lots of other libraries and APIs out there, and you may be wondering whether you can use any of them. Now, for some of them, there are custom bindings, which the Bridge team have released, and one of the early ones was for WebGL, so they could have like fancy demos, or people were saying, well, I want to write games in the browser, and can I do it? Now, the cube here, I'm afraid, is an animated GIF, because I couldn't embed JavaScript into Google Slides. That's why the animation isn't very smooth, and if we stay on here too long, we will probably see it jump quite unpleasantly towards the end. But I recorded this GIF from the Bridge site where they do have a live demo, and it is Bridge code, translated as JavaScript code, and you can use keys and change how it spins around. It's all neat and cute. The Bridge team have also released bindings for other libraries, such as QUnit, because if you're going to write your application in C#, you should be able to write your unit tests in C#. The problem with this is that writing custom bindings doesn't scale very well. It's okay if you don't mind taking a crack at writing your own bindings, but if you want to do quote-unquote real work, then having to do that before you can use it is a pain in the ass. To try and get around this, Bridge team have this project called Retyped, which reads TypeScript definitions, such as from definitely typed, and translates them into Bridge C# bindings. And these are all published automatically through NuGet. There's a lot of popular projects on there already that have bindings available. They are not going to be as good as handwritten bindings. They're often good enough, but there are also places where the types could be stronger and the documentation and the code could be clearer. And in a forum post, someone had asked, look, if you retyped is just busting out these React bindings, as they are with all these other bindings, do we need the Bridge React bindings, which I maintain? And so clearly our boss. The Bridge team responded, and they said that we do recommend that you use those because they will be a better developer experience. Handwritten bindings are tailored to work with C# instead of TypeScript. There are differences between the two. There are things that TypeScript can't do that C# can do. However, the auto-generated ones, it's a good place to start. It's not going to be perfect, but it's better than nothing. Now, you may be wondering, depending upon how super techy the crowd is, about something called WebAssembly. Back in 2011, Scott Hanselman said that JavaScript is assembly language for the web. Now, what he meant at that time is JavaScript is what runs in browsers. It's not necessarily what the code has to be written in, but it has to be compiled down to JavaScript, which is exactly what Bridge does with C#. Last year we started to see this thing called WebAssembly going to be available. It's intended to be a better target to compile to, where better means various things, which I'm not going to go into too much detail about right now. I thought it was worth mentioning, and some of my notes have fallen off the bottom, so I will just make up what I was going to say next. The browser support for WebAssembly seems to be quite good, but what I don't quite understand is I don't think it's a yes or a no thing because it's a moving target. They're going to be adding more features. Hopefully all the browsers will keep up with all these features. At the moment it feels very bleeding edge. People are experimenting with it, but frankly I think it's going to be a while until there's really stable support that's useful for commercial use. I may be wrong because I've not got huge familiarity with it, but that's the impression I get at the moment. If Bridge were ever to make use of this, it would require huge changes. As far as I'm aware, they haven't even suggested that that is something on their roadmap. It's interesting. It will be interesting to see what comes from WebAssembly as we go forward. But for now, I think Scott's probably still right that we should consider JavaScript as the assembly language for the web. Now, getting towards the end, so far it's all been pretty good. It's all been sweetness and light. However, there have been some problems I've had with Bridge. You get breaking changes from one version to another. Sometimes they're planned and documented with breaking changes tagged in GitHub, but it's still annoying. Sometimes it's accidental, and when it's accidental, you then have to wait for them to release a point release. And if you're already waiting for one bug to be released, and then that bug fix includes a new bug, and then you've got to wait for the next version to fix the next one, that way it gets even longer. That's very frustrating. It is open source, so some people might say, well, you can send your own fixes. You can submit pull requests and you can submit fixes for the compiler, but the unit tests for the compiler use a NuGet package that the Bridge team have not made public, so you can't run your tests on the compiler. Now, the reason they haven't made it public is because they're starting this premium option. Now, I get the point of the premium option is to bring some money in to what is otherwise a freebie. If you're a premium member, your bug reports get prioritised and you get access to more resources, such as the bridge test and you get package. The thing is, I think putting that package behind the premium wall is a mistake, because it means that non-premium members can't easily contribute because they can't run the tests. And if the premium members are getting this priority support, then maybe there's concern about how long your issues are going to be waiting around if you're not premium. They have in the past gone through cycles where they do monthly releases and then point releases in between, but sometimes there are longer waits. I think one time there was 3 months maybe. So if you're waiting on a bug fix, you don't know how long that's going to be. That's frustrating enough. When you're feeling like a second-class citizen, and it's going to be even longer, you don't know when it's going to come out. If that's blocking what you're doing, it's not a good place to be in. Now, where I work, we've developed a test framework to use with our bridge projects. It integrates with Visual Studio as a test runner. It runs tests in multiple browsers. It runs on dev machines. It runs on build server. It's great, but it's internal. We want to make it public, but we need time to tart it up really, and that's not a high priority. Even after we do that, it's still not going to run the bridge compiler tests. So that restricted access to the bridge test package, I think, is still a problem. The source maps that I talked about before, I said, oh, aren't these great? They are great much of the time, but the references in the right-hand pane are JavaScript objects. So they've got the C# names, but the JavaScript objects, when you dip into them, they're not as clean as looking at Visual Studio Quick View with real .NET code. You can also use client-side debugging tools, Visual Studio and Chrome, but you have the same problem with the JavaScript object references. Sometimes in Visual Studio the code is a bit off, and I don't know why. Step through sort of works, which is good, but it's, while useful, I just don't feel it's very reliable. So I didn't want to end on negatives, so I thought I'd see how I was doing for time, and although I've taken a little bit longer than I expected, I'm going to power on anyway, so I've got a couple more slides.
Take estimates.
I wanted to talk briefly about the other advantages of using a transpiler on top of being able to just write C# in the first place. One of those advantages is that you can use features that aren't in JavaScript yet. So for example, JavaScript now, or last year maybe, was getting async await, but async await has been in C# for years. So what they had to do was make it work in JavaScript using some sort of state machine approach. You would never really want to write that code by hand, but when Bridge is generating on its own, it's not that big of a deal. Another advantage is that they do something clever around anonymous functions. So if we took code like this, the C# code, and the naive way to translate code like this, which has got an anonymous function inside the where, would be to create an anonymous function in JavaScript. So this is actually quite a nice example of how closely they match up. But anyway, so there's an anonymous function in JavaScript there. In JavaScript, anonymous functions are objects, and a new one would be created every time that where is called, and that gives the garbage collector more work to do. There is an option in Bridge to lift anonymous functions that don't have any outside references into reusable functions. So instead of creating an anonymous one each time, it can reuse the same one. It does lots of clever analysis to work out when it's safe to do that. So it's moved into one called F1. So no new object is created each time. The garbage collector has a little bit less work to do. Bridge doesn't do many other things like that at the moment, but potentially it could do. And if they put that into new versions of the compiler, all you need to do is get the new compiler, recompile everything, and you get improvements on how your code runs without you having to actually change any of your code. You can get little wins for free, if you like. The last thing I want to talk about is, if I'm saying it's possible to write C# to run in the browser, does it only work with code I'm going to write now? Is it possible to run existing code? Now, last year, I had this blog post where I had this little foray into image processing and a little bit of simple machine learning. And it was how to do face detection in .NET, and we used the called .NET library, which I translated into Bridge. Don't be distracted. These pretty sweet moves that are being shown down here. I tried porting this bridge. What I had to do, because it used a bitmap class, I created a version of the bitmap class that would rewrite to a canvas element. I took some of the Accord.NET classes and was able quite painlessly to paste them into my bridge project, and it worked. It's much slower in bridge. I think the canvas is slower than direct memory bitmap access. There was some parallel work that I was doing in my .NET code, which I couldn't do in bridge code. But still, it's promising. If you want to know more, there is a link in the references slides to this GitHub repo. Now, that really is the end. And should anyone have any questions, you are free to put them to me.
Does it support service workers or anything yet? Or do you think that will come in the future? Just because you mentioned about parallelization.
No, that makes a lot of sense to ask. Not easily, because I looked at them when trying to see if I could parallelize that work in bridge. And the way that it wants to work is to have one project with one entry point. And the way with the service work, you want to sort of new one up. So I managed to hack a few things together and it sort of worked, but
not coming soon,
yeah, not easily. Everyone else has just made, okay, race, Craig, you say you can go.
Okay, just a couple of quickies, Dan. Are you concerned at all about one, is the JavaScript that's created, I appreciate you're not directly debugging it, the JavaScript that's created for Grid.NET, is it particularly idiomatic JavaScript? I'm guessing it's not as idiomatic as it would be if you handcrafted it and you were a very good JavaScript developer. And secondly, would you reconsider going down a TypeScript route?
Okay, both good questions.
Given both the progress in the intervening years as I know.
Yes. Let me start with the first question. I would say where it's possible for the code to be idiomatic, it's fairly idiomatic. Now, it defines classes using a helper method called bridge define class. It's not ES6 classes, and it's not quite plain objects. Much of the code will be quite idiomatic. So if you look at the Pong example, you look at the generate code, you'll be like, that looks quite clean, that's nice. When we were looking at the anonymous function and the link clause, that is quite idiomatic. Other times where you've got a lot of lambdas, and if they all get lifted into reusable functions, that's harder to follow, and that's not idiomatic. Where you use async await, and it creates these state machines, that's, you're looking at that and you're like, I don't know where this has come from. Even if you do know where it's come from, you don't know where it's come from. So in some cases, yes. In some cases, no. One of the things I would say, though, is that personally, I spend much less time debugging JavaScript now than I did when I wrote JavaScript or even TypeScript, because I can get the code right more often, straight away, with all the tooling and strong typing. So, although it's maybe not as easy, I spend much less time doing it. Now, TypeScript, I am impressed with where TypeScript is now. Especially with their non-nullable handling option, that's fantastic. The biggest thing for me that TypeScript doesn't have is the same level of code analysis. You can write analyzers like ESLinters for the file that you're looking at, but where Roslyn can say, right, you are calling a method in this assembly over here, and that method returns you an object which implements an interface over here, and that interface, this solution-wide, including external dependencies, analysis is next level. And I think that's the way that we're going to improve code quality. And it doesn't exist with TypeScript yet. No. There's been talks in the past about maybe it would do, but they said the TypeScript compiler at that time was too limited, and it was too tuned to sort of single-threaded, compile as quickly as possible performance. Whether that will change in the future, and whether we'll have to do clever things to talk to other libraries and work out those dependencies, because they don't have the same level of metadata that .NET assemblers do. That's what's put me on the edge, because I was impressed, and I think if I spent enough time with Gulp or Grunt, I would master it eventually, and that wouldn't be a problem. But that's the problem.
Do you ever find that there's things, I know you gave the example of async and wait being, it's not actually supported in JavaScript, but then works in C#. Do you find that it works identically to how it would work in C#, or have you come across anything where it is subtly different?
I have not come across anything where it's subtly different. That's not quite the same as me saying, does it work exactly the same? It works close enough that I haven't noticed any difference. So, essentially, yes. One downside that I sort of didn't mention, that to do with the fact that this project is maintained as an open source project and they have their own priorities, is that currently they're limited to C#6 syntax, and they need to do work anytime that we get new syntax. So that's reminded me of that. I don't know what their timeline is for C#7, and it seems like new versions of C#, the rate at which they are getting put out is accelerating. We've got C#7, 0.1, 0.2, 0.3 is coming soon. Features keep getting pushed back because the release schedules are much more frequent than they used to be. That's a limiting factor with Bridge. It would be great to have those features as soon as they come out, but we don't. Any more for any more?
Thank you, Dan.
All right.